All right. So, would you find your notebooks, please? We are going to start chapter 9 today. Okay. On Friday, we watched this guy here through 7 different shots. I'm not going to tell you which of the 7 you're looking at right here, but the question is, do you think he's going to make that shot?
No. It's going to be short.
Okay. How many of you right now, and how many of you right now would say yes? You think it's going to go in? Okay, fine. Let's go with this. Not sure if it's going to go in or not, but definitely is going to make contact with something.
Yep.
How many of you are yes in that scenario? Okay. Anybody a no in that scenario?
I feel like that's a trick question.
Yeah, it's possible, right? When we watched the videos on Friday and made our decision about whether the ball was going to go in or not, every single time we saw something happen with the ball. We saw it at its vertex, right? Its highest point. Do I know its highest point given that scenario?
No.
What's up? Say that again. Oh, well, what do you think? Okay. So what if I give you another picture? The ball will still be above the tree right here, but there'll be one more location of the basketball along its path. So does that help you determine whether the ball went in or not? So there's still the ball above the tree, but here's another picture of it over here, helping its flight path. Yes, sir. Will it hit the rim? No. Long or short? Okay. Anna, what do you think? Hit the rim? Yeah, yeah. What? Go ahead. What do you got? Your justification for why you think it's going to be short? Sure. Okay, so you're thinking the one here is telling you that this thing is okay. All right. Logan, what do you think? Okay. Tell you what, I'm gonna give you one more picture. So one more position of where this ball is located. What about now?
Oh,
I told you. When we see this one up here at the top, what have we just learned? What? Yeah, we know which video this is now. Yes, the one that bounced in the middle of the lane that did not make it all the way. Yeah, looks like Caitlin, right? If we thought about just the first one, we probably could create some kind of path that would put the ball in the hoop, and maybe even from the second one, something very similar. But as soon as we get the top one to come into play, and now realize that the ball did that, it wasn't going to happen. Okay, and in this scenario, it's this point up here that was extremely important to us in that path. And so that's one of the things we're going to talk about today is if I don't know this point, the vertex, how do I find it? What do I need to do in order to make that happen? Okay, it's one of the key characteristics of a quadratic function. All right, so our 2 goals for today involve that idea of finding the vertex, and we're also going to talk about what's known as the axis of symmetry. Symmetry means what? Symmetry means good. It's the same on both sides. And in fact, that line of symmetry, if we come back here for a second, that line of symmetry is going to go through my vertex. Okay, so they almost kind of work hand in hand with each other. And then the other thing, and actually what we're going to start with, is this idea of what's called a zero of a function. I called it characteristics of quadratics. It's not really even the first section. The first section of this chapter is actually graphing, but I felt like these 2 things, because they are so important, really should kind of lead us off. So I titled this, if you look up top, at section 9-0. As if we didn't have enough, I created more. So sweet. All right. So we're going to start with this idea of a zero. And I know this looks a little bit wordy. You don't need to write all this down. If it was me, I probably would put the pictures down just in a little sketch. But here's really what's going on. A zero of a function is any value of x that makes it equal to zero, makes the function equal to zero. Essentially, it's the same thing as a as an x-intercept. Okay, a zero of a function is really the same thing as an x-intercept. And when you talk about a quadratic or a parabola, that can happen in one of three ways. We can touch the x-axis once, thus having 1, 0. We can cross it twice, so having 2 zeros, or it can happen not at all, meaning it's below the x-axis and it stays down there, or the other option obviously would be if it was above and stayed above. Now, we've talked about this word zero before. We actually said there were 4 things that were really synonymous with each other: a zero, an x-intercept, a solution, and a root. They're all talking about the same thing: finding the value of x when y is equal to 0. And graphically speaking, that happens at the x-intercept. Okay. I'm going to come back to this picture in 1 second, but in our last chapter, we saw things that looked like this. Yellow's probably not a good choice. Could you factor that? What multiplies to 12 and adds to 7? So can you tell me how you would factor it if 3 and 4 are the right numbers? What would be in your parentheses?
X plus 4. And on the other side, x plus 2.
Okay. If this was an equation that was set equal to 0, how many solutions would there be?
2.
2. What would those 2 solutions be? They would be
Negative 4 and
-4 and
negative 3.
-3. This quadratic right here is an example of something like that because it has 2 answers. Okay. If it did have a solution of -3 and -4, then graphically speaking, we would see it cross the x-axis at -3 and at -4.
So if it was like a prime, would that be 0?
Ah,
Or like no zeros?
yeah. When you guys took your test last week and you couldn't figure out what the numbers were that factored, and you were like, "Oh, I'll just write prime," right? Some of us did that, right? If it truly didn't have any factors, that's exactly what's going on over here. There were no factors because there were no solutions because it did never cross the x-axis. That graph never crossed the x-axis. Okay. Here, this is something factorable. Right? Maybe it's what multiplies to C that adds to B, or maybe it's the ACB formula, or maybe it was just the greatest common factor that was able to pull those exponents apart for me to solve. What would this be? Can you think of something that only would have had one solution? Jack? A perfect square. Very good. Something that had the exact same factor twice is really an example of a perfect square. And graphically speaking, it only comes and touches the x-axis once. So a lot of what we're going to look at as far as these solutions are concerned really can be tied right back to factoring. Okay. Now, if you're putting this all together in your head at this moment in time, you may start to realize that I can get an answer algebraically through factoring, or I can get an answer graphically through seeing what it looks like as a picture. Okay. So both of those are options for me as far as getting an answer. And maybe some are better than others, and maybe one way's easier or quicker, depending on what you have available. But understanding how these zeros relate to the factors of a quadratic can be quite helpful for you. Okay. So if we look at something like these two, how many answers are there to the first one? Or how many zeros are there to this one?
2.
And they are Yeah, what are they? What are the values of x when y is equal to 0?
-1, 0.
So -1, this one over here, and 3 and 0. And if you looked at this equation, because it has two solutions or two zeros, then you should be able to factor it into two factors. Meaning, if you thought about this, can you give me something that multiplies to -3 that adds to -2? Can you think of something that multiplies to -3 and adds to -2? Not a whole lot of options for multiplying to -3, so this shouldn't be too difficult.
-3, 1.
Good. A -3, so x minus 3 and x plus 1. The first factor, x minus 3, what makes that turn into 0? An answer of what?
+3.
A +3. That's why that one crosses at 3. Why? What makes this one equal to 0? A -1. That's why that one is equal to -1. Okay? So those solutions are exactly the same things that if I had set this equation when y is equal to 0, that makes that work. Okay? Looking at the second one, it comes down and touches the x-axis once, which means it must be a what? It must be a perfect square. So tell me the two numbers that multiply to 16 that add to 8.
8 4.
A what? A 4 and 4. So really, if I factored it, it would be x plus 4 squared. Well, what's the one number that satisfies that equation? It would be right there at -4. Okay? Roots, zeros, x-intercepts, solutions, okay? That's what we're looking for in this scenario. Now, the other piece that we have to get into today is this idea of what's called the axis of symmetry. Okay? The axis of symmetry always goes through my vertex, number one. It splits my graph into two equal halves, all right? And I can use those zeros to find it if necessary. Okay, so the axis of symmetry. You all right today? Huh? You listen to the smooth sounds of Mr. Coughlin just putting you to sleep?
Yeah.
That's cool. I got a voice like Barry White or something?
I don't know who that is.
That's cool, because I'm old and you're not.
Yeah.
Hey, stop being nice and don't agree. Got it?
Okay.
All right. All right. So, if you want to talk about an axis of symmetry, can you tell me where it is in this first one? Can you tell me the vertical line that splits your graph into two equal halves? Okay, where is it? It's at -1, right? So here, if we drew a vertical line through -1, that is the line that splits my graph in half. When you have a perfect square, that axis of symmetry goes right through your one and only solution, because your one and only solution is at the vertex. In the second one, can you tell me where the vertical line is there? Belle, you know where it's at? Good, it's at 2.5. When you have two solutions, that vertical line is going to go halfway between those two solutions. So one solution was at 1, the other one was at 4. Halfway between 1 and 4 would be 2.5. Are you with me so far?
Yeah.
Sure.
Where'd I lose you? Oh. Can you tell me the equation for either one of these lines? Do you know how to write the equation of a vertical line? I promise you, it's very easy. It's almost too easy. It's not y equals because this never crosses the y-axis. So x equals m, or x equals, there you go. Just right. It's literally that simple. This one, x equals -1. The other one, x equals 2.5. Okay. Now, why is it important to know that? Well, your axis of symmetry goes through your vertex. And so what you know by knowing that line is you know half of your vertex. So for example, here, I know that my vertex is going to be 2.5 comma something. And we'll talk about how do I find that something here in a minute. Okay. I know that the x value from here to that line of symmetry will be 2.5 units over. here, it'd be -1 comma something, and obviously in this case that something would be a 0, okay, because I have that one there. So if I have one solution, it goes right through it. If I have two, it splits it in half. What's the third option for zeros? You could have one, you could have two, or you could have none. So where does it go if you have none? Like, well, where does that axis of symmetry go? Like, what if you had a picture like this and there's your parabola? Where's the vertex? I don't have two solutions to split it in half. I don't have one. Like, if this parabola was down here, like, and I had an answer at 2 and I had one at -5, I could find the middle. It's halfway between them. If it just barely touched once, I could have one. I'd know where it was at. If it's up here, where is it? Right about, right? Like, where is it? Okay. So if my picture doesn't help me, or if I don't have any, or I don't have a graph, then we have what's called the axis of symmetry formula that we can use. Okay. This formula will be on your state test. To the best of my recollection, remembering from 2 years ago, I believe they give it to you. You just have to be able to execute it or use it. So here's how this formula works. We should know the values of A, B, and C in an equation. We've done the ACB formula for factoring, right? A is the value in front of the squared term, B is the value in front of the X, and then C is that constant on the end. In order to use this formula, we need two things. We need to know the B value and we need to know the A value. Okay. Now, this formula does include a negative, so I will always read it the same way. I will always say that X is equal to, and I read it like this, the opposite of B over 2 times A. I put the negative with the B. Meaning, if the B value is positive, I'm gonna make it negative. If the B value is negative, I'm gonna make it positive. Okay? That axis of symmetry is 1/2 of me getting to the vertex, and the vertex is something that I need when I'm talking about a parabola. Okay? So let's try it with this one. Can you tell me the value of A in this equation? Carly, what's the value of A? -3. Ben, what's the value of B? 10. And Nick, what's the value of C? 9. Of those three, which one do I not need? I don't need the 9. I don't need the C value. Okay? I need the A value. I need the B value. So in my equation, I am going to write the opposite of B. So B is 10. So I'm putting in what value? -10 divided by 2 times the A value. And in this case, A's value is -3. If I can find that number, then I can find the axis, the vertical line that is going to split my graph in half. And remember, that line goes through the vertex, which would be something that I'd like to have. So use your calculator. Tell me, what do you get for that answer? Ben, what do you got? -15. Now hold on now. There's two negatives in here. +15? Quinn, you agree with that? Aiden, you agree? I don't agree. I'm sorry. You got fooled by your order of operations. What you got? 1 2/3. 1.6 repeated. If you type this in as you see it, -10 divided by 2 times 3, what is your calculator going to do first? It's going to divide, right? Because division and multiplication are on the same level as each other. So it's going to do the division. But I don't need that. I need the multiplication on the bottom to happen first. I need to do that. Negative 10 divided by negative 6. And I would say you could either say 1 2/3, or you could say 5/3. I do not want you to put 1.6 repeated. Because if I have to use that number and I have to plug it back in, that repeating decimal is not going to play nice. Okay? How many 0.6s is enough for me to get that? That's not a game I want to play. Okay? Now, that number right there tells me that on a graph, I vertically need to move, or excuse me, horizontally need to move over 1 2/3 units to find that vertical line that splits it. Okay? But regardless of any axis of symmetry that I find, that x value is guaranteed to be part of my vertex. Okay? So, if I currently know the vertex has an x value of 5/3, how do I find the rest of it? How do I find the rest of the vertex? I'm going to use that 5/3 somehow. Okay, do you know?
I was gonna ask if the other one's 9 because we didn't use it.
True, we did not use the 9. And I will actually use the 9, not by itself, but I am going to use it. You know?
Plug 5/3 into X.
Good. I'm going to take this 5/3 and I'm plugging it back into both of those spots for x. Because that equation is equal to y. So if I plug in the x value, I should be able to find its corresponding y value. Now, if I use my calculator and I use my parentheses correctly, I should be able to type all this in. So my calculator should look something like that. Anywhere there was an x, I'm going to put in a set of parentheses and replace it with a 5/3. Have you done that yet? That's what I got. You got an answer? Again, here you're going to end up with a decimal, a repeating decimal if you do it correctly. So I would, yes. So I would either put it in as a mixed number, or you could do it as an improper fraction. Logan, what do you got? 17 1/3? Or we get like 52/3. Does that sound right? 52/3. You could go that route if you wanted to. Don't put 17.3 repeated. All right. Now, can you visualize for me, where is that order pair located? First quadrant, second quadrant, third, fourth. It is located in the first quadrant. Over to the right and then up. Because they're both positive, right? I will tell you right now, and we're going to get more into this tomorrow, this graph, negative 3x squared plus 10x plus 9, faces down because of this number right here in the front. The fact that its squared term has a negative in front of it means my graph will face down. How many solutions will I have to this graph considering my vertex is in the first quadrant and I know that my graph faces down? Let me just visualize that for a second. If you were, here you are, your ordered pair is somewhere here in the first quadrant and your graph is going to face down. How many times is it going to cross the x-axis? Andrea, how many times? How many? This graph has a vertex up here and it's going to face down. It's going to cross it twice, which means it ultimately will have two solutions, 2 zeros. So could I factor this equation? I could. And how many factors would it have? 2, because it ultimately has how many solutions? It has 2 solutions. Okay? All right. So with that idea, I would like you to try this one here. Okay? So same idea. Can I find the x coordinate through the axis of symmetry? Can I find its corresponding y value? And then can I write it as an ordered pair? And we'll see. There's a picture of it over here, and we'll see how well your picture matches the vertex you claim to that picture that's over there in the corner. So with that equation, using this axis of symmetry formula, so remember that is x equals the opposite of b over 2 times a. What's the x value? Once I find it, what's the corresponding y value? And then what's it look like as an ordered pair together? Now, what happened to some of you guys in the last one where we thought maybe the x value was going to be a 15, that will happen to me every time I use this formula. So please make sure that you get your denominator together first before you end up doing numerator divided by denominator. Once you find your vertex, tell me, how many solutions do you think this problem will have? So opposite of b, so that's going to be a -2.
Oh.
So we'd want -2 divided by 2 times 0.25. This would be my x value. If you want to type this axis of symmetry equation into your calculator in one group, you're going to need to put parentheses around your denominator. It's going to have those two so that your calculator knows to do that first. Or find the answer to the denominator and then do -2 divided by that number. Can somebody tell me what is the x value that you get to this? Anna? -4. Very good. Okay, so then I know -4 comma something is my vertex. Take that -4, it's got to go in for the x squared and it's got to go in for the x. Use parentheses. You can type it in one string as long as you put your parentheses in. You should get another negative number. Go ahead and you have it? Oh. What's that?
So what do you do after the -4? What do you mean?
So it's going back into that equation. So it'd be like 0.25. And then instead of x squared,
Oh.
-4 squared. So just literally right down the line. Yes. What happened? You forgot your squared. There should be a squared on there because that's 0.25 times x squared. So that should be my number. Yes. So when you plug a -4 in here, you get what for an answer? You get, Aiden, what do you get? -1. All right. So if that's true, what quadrant is that order pair located in? In the, try again. Third, good. So you're left and then down. Which way is this graph facing? If you come back here and take a look at this equation, which way is it facing? Up or down? Logan? It's facing up. This value right here in the front by the squared, If that value is positive, it's facing up. If that value is negative, it's facing down. So this graph is in the third quadrant and it faces up. How many solutions? Two. All right. So take a look at this picture over here. Is -4 and -1 the center of this graph? -1, 2, 3, 4, and -1. There's the center. There's the vertical line that splits it. And my solutions have to be the exact same distance in both cases, are they? Well, that one's at -2, that one's at -6. That would split it in half. Okay? Last question for the day, and then we're done. No homework tonight. Okay? So, here it is. Oh, sweet pearl. Look at all those words.
Yeah.
All right? Okay. So, there's the function. It can be used to model the height in meters of an arch support for a bridge. Okay, so if you're thinking arch of a bridge, you know, something like that. All right, I mean, we could get all fancy over here, right? Look at all this brickwork on my fancy arch. Yeah, I know, you're seeing it. All right. Oh, it's just, you know, it hasn't been done yet. Okay, let it take time. Yeah. Okay, so it says the x-axis represents the water level. And x represents the distance in meters from where the arch support enters the water. The question is, can a sailboat that's 14 meters tall pass under the bridge? We've all seen the video of the semi-truck driver who tries to go through the tunnel and his trailer gets just flat out demolished when it doesn't fit. How many of us have seen that kind of video? Those are hilarious. Like, you got to think when you're going 70 miles an hour towards that tunnel, like, man, I wonder if I'm going to make it through here or not. Like, they still go for it though.
Truck driver and one of his other employees,
Yeah.
whatever, they did that. It was in Akron, and him and
Yikes.
his other buddy went out because there was so much.
I can't even imagine.
The trailer
Oh man.
on the highway.
Yeah, not solid. So here's the question, right? There's the water going through the bridge. Here's the best boat I know how to make. Okay. That thing's not even in the water, it's floating on top of the water, okay? That's the skill level I got, right? But the question is, if the sailboat's 14 meters tall, does it fit? Well, what part of this arch makes that determination about whether or not it fits? The top of it. So the question really becomes, what's that point at the top? And how do I find it? All right. And so it's some ordered pair. Which one of those values in that ordered pair do I actually care about to answer this question? Do I care about the x value or do I care about the y? Which one? I need the x, but remember, I'm talking about vertical height. So I care about the y. Okay, so take a second, see if you can't figure out what's the x value and what's the y value. Now, I will tell you, the x value is a positive whole number that fits on one hand. So if you get an answer of 1, 2, 3, 4, or 5, you better retry that x value.
Wait, it's not an answer to that, or
It is. It is.
Wait, why did you just say if you didn't answer 1, 2, 3, 4, 5?
I said if you didn't get an answer of 1, 2, 3, 4, 5.
Okay, so this is.
So opposite. Oh, neither. So opposite of b would be negative 0.6 divided by times.
Oh.
You said oh. Okay, so your answer is okay. Is that your answer there? So it can or cannot? You just raised your voice. It means you just asked me. find that value of x, that axis of symmetry. Bless you.
Wait, what are you doing?
What's that?
Can I plug it in?
Yeah.
Okay, wait.
So, yep, take that number now.
What's your clock on?
What?
It won't let me go there to fix it.
Hit second and enter. There you go. Oh, yeah, change that to.
Yeah.
There you go.
Is that right?
Uh-huh. So can somebody tell me what's the x value in this problem? Bella, what is it? 5. Very good. So I know that that ordered pair that's at the top of that arch is 5 comma something. The something is the thing I need. If it's bigger than 14, float away, my man. You're going to make it. If it's less than 14, depends on how much you like your sailboat. Or if this is one of those cool bridges that opens up. But I'm thinking if that's the support, it probably ain't opening up. It's not typically how a support works. If the support were to open up, I think she'd all come crashing down. What? What do you think? You always give me these judgmental eyebrows. Always. What do you think it is?
11.7.
Okay. So if that's true, what's your answer? If my answer is 11.7, what's the answer? Am I making it?
No.
He said, turn around, buddy. Right? You might want to pull the, what do they call that little plug in the back of your boat, you know? Yeah, so like you pull that and let it sink a little bit, maybe you could make it underneath. Okay. But at this current point, if the top of that thing's 1176 and your boat's 14 meters tall, you can shimmy up that pole and cut part of it off, or turn her around and go the other way. You ain't making it. Okay. So that vertex, though, is what allows me to make that decision in this case about whether or not that works.
I kept thinking I was wrong because when you said it was a whole number that you can count on your hand, I thought you were talking about the Y.
About the Y value, not. Yeah. So tomorrow, as we kind of move forward with this idea, we want to keep in mind that axis of symmetry that leads me to my vertex is really the beginnings of how I start a parabola. All right. No homework tonight.